Well, we have one section in, okay, oh, by the way, I'm so happy you said that. So, one of my major nemesis, like a nemesis, right, is a person known as Past Jeff. And for some reason, that's me, Past Jeff, let me see, I'm trying to find my little notes. Where did you go? Here you are. I was looking at the homework sheet and I was like, oh, how am I supposed to be getting in chapter? If you look at the homework sheet, May 17th just sort of disappeared. I like pretended it didn't exist. So here's what's gonna happen. Test 3, which is currently scheduled for May 10th, we're gonna push it to May 12th. Everybody with me so far? Is that a problem? I'm sorry.
No.
Is that right? Okay. And then chapter, I know this is a little in our future, but chapter 8, we will be in there May 17th and 19th instead of May 12th and 19th. I just sort of forgot about May 17th for some reason, which is always exciting.
Does that change the next thing too? So it says 9 is May 19th and the 24th.
Yeah, that stays the same.
Oh, okay.
Yep.
So we're doing 8 and 9 on the same day.
Second?
We're gonna do 8 and 9 on the same day?
Yes.
Okay.
We're going to be finishing one up and getting to the other one, yeah. So today we're going to finish up chapter 6, and then we'll get into chapter 7 next time. Yeah. All right. I like it. Anything else from homework or general questions or grievances you want to air or comments you want to make? Yes?
For the 31st, that class day, which is a Tuesday before the finals, because it says on May 26th we have a review for the finals.
Yes.
Are we still having class on the 31st?
Isn't that when finals start or no?
I think
Yes.
so. This is
That's
like-
finals week, if I remember correctly.
Yeah.
So check me on that. But once finals start, no class meets at the regular time anymore. That doesn't exist anymore. Everything is just your final.
This is my first
Understood?
in person.
Yeah.
So I didn't know.
Because when they schedule the finals, like I said earlier, they've got to find enough time, so they have to redo everything. So normal classes don't meet. It's all finals. So you only have to come again when it's final exam time. Yeah.
Okay.
I appreciate that though. You have to look out for me because I do things like that. Okay, so what I really want to do, to be honest, I have a little practice sheet before we get into 6.3. So this one's focused on 6.1, 6.2. So I'm going to give this to you. I'm going to let you kind of work on it for a little bit by yourself, and then I'm going to try to put you with some other people, right? So that's a very short, let me see if I can, all right guys, let's see, let's talk about these. Does anyone have what they think is a great or an okay answer to number 1? Yes?
I put anything over itself equals 1, so like 4 over 4, 7 over 7.
I like
that.
it.
And then I said anything that can be divided by 0, so like 0 over 2.
Okay.
Because that would equal 0, and
Sure.
it's still a whole number.
So you got the subset of fractions that go to 0 or 1, right? And that's good. I like it. Yes?
I said fractions with a denominator of 1 are whole numbers.
I love it. So that's sort of like the other way. You say, well, every freaking whole number is a fraction, Jeff. So there you go. I love it. Now, anybody else got anything more general than something divided by itself? Or 0 divided by anything? What's a fraction equivalent to 3? Give me a fraction that's equivalent to 3. 9 over 3, right? 9 over 3. So that fraction is a whole number, correct?
Yeah.
What's special about it? Why does it become a whole number?
Because it goes into it evenly?
Yes, 3 goes into 9 evenly. I'm sorry. So if I have a fraction like this, let's see if anybody can write this using the notation that we learned before. What must be true about B and A? There's a special symbol you could use.
It divides.
Yes, dude. So B has to divide A. This is a whole number if B divides A. Because this symbol means it divides it evenly. So you can just say it in words, it's beautiful, or you can use this notation. Is that cool, guys?
Very cool.
All right, or understood at least. You gotta remember, use the word cool, I might get less agreement. What about, so 2A, there were like 2 main ways to answer 2A. What do you guys think the answer for 2A is?
Greater than.
So yeah, this here, what was it, 30?
Good.
5, yeah. So how did you determine, so you got like this?
Yeah,
So how did you determine this?
because 2/5 can become 14/30.
Okay, I like this. So this can become 14/35, which is obviously bigger than that.
Yeah.
I like it, right?
Yeah.
Or it could become 12/30. And since this is being divided by more, this one is smaller. Did anybody else do it even another way? So that's one way, is to kind of blow one of them up and then make it comparable. And I made the bottoms nice, right? Is there another way anybody did it? You're all like, that's exactly what I did. Yeah, you did it a different way? Oh yeah, you did it a different way. What's your way again?
I did a 2/5 equals 40%, and I made the 36 to, or 35 to 36, and 12/36 is 32%, and 40.
It's like a third, right? A third is like 33%, right? And one thing about that is you sort of brought decimals through percentages, but I'm still like, that's fine. Because you really didn't do any calculator work, because you didn't have one. So you sort of looked at it that way. I love it. Okay, so if I don't say to do it a certain way, and I did say you couldn't use decimals, but if I don't say to do it a certain way, there's a lot of different ways you can do it, as long as you kind of explain yourself. Don't just throw the symbol in there and keep going. It's not good enough. Okay. What about part B, where I threw at you slightly larger numbers, and you can use your calculator? Does anyone remember the method to do exactly what this problem is asking us to do? There is a method that was built to do exactly what this is asking us to do.
Well, you mentioned it, cross multiply.
Remember this, guys? Guys, you could have done this on the first one also. 870 times 18, right? And I said you could use your calculator, so you don't have to do that by hand.
15,660.
15,660. And then 45 times 348.
15,660.
There you go. So these are equal. Now you could, what can you do with 18/45? Just with that fraction. Can you simplify it? 11. Reduce it, right? And you could also reduce this thing. But that would take probably more time than just throwing this in your calculator, right? So don't forget that cross multiplication process. It comes up every now and again. Don't forget it. Okay. Hint, hint. All right. Let's see. Oh, 3, I kind of left it really wide open, but I want to see if anybody remembers the kind of obscure way the book did it. But I'm open to anything. So 8/15 and what does it say? 19 23rds. Yes.
Just add them across.
Yeah.
Like,
So
add the 2 top numbers, then add the 2 bottom numbers to make a fraction.
and I think I can't remember if I really sort of showed you what the proof would kind of look like. I didn't really spend that much time on it, but
With the
it seems
diagram.
counterintuitive, but we're not adding the fractions, we're finding a number between those fractions. So this is just a process that happens to do that. There's a proof for it. I can't remember how much I kind of went down that road. So yeah, you get 27/40. Or, Jeff, you can do better than that. 38.
Yeah.
Does anybody else, oh, good.
Because you said any fraction between 28, 38, so that would also count? Because
Yeah, exactly, yeah.
Yeah, you're not skipping over to the 20.
As long as, but then you have to make sure that you don't pass this guy up.
Yeah.
Yeah, so any other answer you get, so did somebody do something different for that one that wants to, this is not the only way to do it. So if you did something different, doesn't mean you're wrong. Did anybody do something different? You all did that, is that what you're saying? I know that's not true because I saw some different answers, but I'll take that.
Could you show us a different way to do it?
Sure. So here's like the obscure textbook method. The one that involves more work would be get an LCD, right? And the only saving grace of this problem, I was talking to somebody earlier about exactly this. When will the numbers get really big, but the LCD is easy as shit, is when the two denominators you're looking at don't share anything. Then they both need each other, right? So 15 is 3 times 5. 23 is 23, right? Do they share anything? No, so they both need each other. So I would give this guy a 23. Let's do this. See where this is going. And I would give this guy 15. 23 times 8 is 184. 23 times 15 is, I don't know, something. 115 times 3 is 345. Is that right?
469. Oh.
I'm trying to get the bottom here.
Yeah.
Let's see, 345, yes. And then this one would be something 285 over the same thing, Jeff. Good job, man. And then I can find a whole bunch of numbers between them, right? A bunch of fractions between them. But that's kind of gross. Why would I do that when I have, this? Another way that I saw somebody do, that's for some reason they don't want to fess up to it, and I think I might know why, is which one of these fractions is bigger? Can you tell just by looking at it which one's bigger?
1922.
No, 19 over 23 for sure. Isn't 8 over 15 just barely above half?
Yeah.
8 over 16 would be half. 8 over 15 is just barely over half, and this dude's almost full, right? Yes?
So with that being said, would it be okay if you did like a measurement of distance, so subtract the denominator from the numerator and then compare that way, or does that not always work?
That sort of points you in the right direction, but it doesn't always immediately give you the answer.
Okay.
Does it make sense? So yeah, these are 7 apart, these are 4 apart, so that points to that being larger, but you have to be careful about doing that. Yeah, especially when the two distances are close to each other. Then you can't really know. So, but I appreciate that thought, but it doesn't always, it's not a hard and fast rule. Yeah. So this is one way to do it, this is one way to do it. Another way to do it is just say, how about 9/15? You just have to show me that it's less than this, which involves work, right? So, but it kind of makes sense. That's way bigger than this.
Yes.
It's easily bigger than this. So maybe just barely above 8/15. Maybe that's in between, but then you actually have to show me. Okay, I like it. So I just want to put that up there because I saw that on somebody's paper, but it would take a little more work to show me. Okay. You guys with me a little bit? I really want you to, obviously with the manipulatives and all this kind of stuff, trying to get a better feel for fractions. If you have a lot of trouble with fractions, don't feel too bad because my calculus students have trouble with fractions sometimes. At the same time, what is one reason you might have trouble with fractions? Holy shit, right? And unfortunately, that is a common problem, right? And what are you going to be doing possibly? Teaching people fractions for the first time, right? So you can be their first interaction with fractions, and what should you desperately want to be able to do for them? Give them a good freaking experience with fractions. Because you should know. Now right now, some of you guys might be like, fractions are just weird, I don't understand them, it's only for certain people to understand. That's crazy. That's not true. If you have a better foundation with them, you can understand them, of course. And you're going to be laying that foundation. So you should feel very motivated to learn more about fractions and how to teach them and all this kind of stuff. Okay. Go beyond what I do in this class, because there's more ways to do it than what we're looking at. All right.
might take your class again, just for the fraction.
Oh, just for the fun of it? Just for the fraction, all right. I'll call it that. Welcome to Just for the Fraction.
Just for the fraction.
So that's that one, let's see. Why is number 4 easier? Yeah, but is there something between 8 and 9? Not really, because I need a whole number, right?
You can multiply both of them by 2.
Yeah. So it's basically doing this, but I wouldn't do that here, because that's gross. I do this. But this one, why can't I necessarily do this? Because I have to find it exactly halfway. But I want to show you something kind of interesting. 16/30ths, and I've multiplied that by 2, 18/30ths. So obviously, what's right in the middle?
17/30.
Now, apply this method to this. What do you get?
Exactly the same thing.
17/30, holy shit, right? That's kind of neat. So if these two are perfectly symmetric, I think that method actually comes out to be halfway. But they have to be perfectly symmetric around, well, of course they would be, yes.
So you're multiplying by 2 because the denominator is the same?
And I only want this, like, watch this. Why is this a really easy question? What's between 2/5 and 4/5? Why is that so easy a question? There's 3/5. That's it. That's the one in the middle, right? So what's wrong here? Well, 8 and 9, I didn't leave any room.
Oh.
But if I build it up, now there's something between 16 and 18.
So technically I could multiply anything? Or do I have to?
Yeah. I could have gone beyond 30, right? Could you find something between these two? Yes, right? When I just double this and double that, make it out of 60? Do you see that? Well, let's see. What would be between these two? If I double this guy, 34 out of 60. If I double this guy, I get
36.
So wouldn't 35 out of 60 be between? Then, can you get something between these two? Yes. How long could you do that for?
Forever.
Forever. Until the cows came home and they did everything and they had other baby cows and those cows came home. Sorry, I'm overusing that. You guys have heard the phrase, till the cows come home, right?
Yeah.
You've never heard that phrase? Okay.
After college.
So that's an old time. Jeff's an old man. All right, look up that phrase, kids. Until the cows come home. All right. That's that one. And then the last one is really just a straight up, nothing tricky there at all. Just do it, right? What do you have to do first here, technically?
With the same denominator.
Where'd it go? There it is. Do I have to get the same denominator between all three of them? No. I mean, technically I have to do it here first, but the parentheses don't even need to be there. Is that cool? Because it's plus and minus, so I can actually kind of move those around. But let's go ahead and do these two first. So that would be, what do I need?
2.
Yeah, multiply by 2. So we get 10/4, right? Yes? 10/4 minus 1/4. 9/4. Right? And then what's the LCD between those? 12. So I multiply this by 2, this by 3, 14 plus 27 over 12.
41.
41 over 12, which I saw all over the place. And then, of course, I said,
Whole number.
make that thing proper. Right now it's improper.
Next number notation would be 3 wholes, 5 12s.
Yeah, 12 goes into 41 3 times, which would be 36, with 5 left over, 11. Now, here's the thing. You guys really don't have a lot of work to do. What number up there is below this that you wish was up there? 36. Well, how far away from 41 is 36? 5. 36 divided by 12 is 3. There's the 5/12, that's extra, right? Maybe? Okay, all right. Any questions from that? I mean, this is, what you really need to start realizing is the stuff that we talk about, sure, in class we can kind of review and so forth, but eventually you're going to be the expert. You're going to have little people there to learn from you. You need to be comfortable with this. You need to enjoy this. or at least not let any disdain show, right? All right, because that's what sets somebody up for future.
You're like, fractions.
Oh God, kids, oh, let's try to get through this.
Let's put it on a movie.
And there's teachers that basically do that. I see them. And then what, the kids, what the hell? They're gonna learn, oh, this is shitty for them. And he's a math teacher. Anyway, let go of that memory. All right, so that's 6, 1, 6, 2. Let's do 6, 3. So you guys can reorient yourself if you like. So we're going to get into some weirder territory. So I really hope addition and subtraction of fractions makes more sense if you just realize you need like terms to add or subtract. And that's all LCD is trying to do, right? Maybe? Okay. There we go. So what we're about to get into, obviously, is multiplying and dividing. Good Lord, yeah. Ciao. So let's see, recall, what's 3 times 2, what's that mean? 3 times 2, what's it mean? So tell me the answer, tell me what it means. It's one way to look at it.
Roots of 2.
Yeah, good. Repeated addition, right? This would be 2 plus 2 plus 2. 6. Amazing, right? Of course, we don't do the middle step. We memorize the answer. We keep going. So now, what is 3 times 1/4?
3 roots of 1/4.
Yes. It's got. I could have put anything here, right? If I put m, that would have been m plus m plus m. If I put 78, it would have been the same. So 1/4 plus 1/4 plus 1/4 is
3/4.
3/4. Okay. Now that is the foundation. That's the underlying idea. Do we actually multiply these fractions like this? Do we do that? Thank God, right? Because what if it was 80? Here we go. No. So, real quick, little side note. This is a little ahead of where we officially are, but we know this. How do I represent this and get there without doing this step?
Put 3 over 1.
Yes. So we still have to investigate why straight across multiplication actually makes sense, but this is how we do it. I won't start singing to you. This is okay. Now. Oh shit. What is this? I mean, it's the same thing, right? I understand it's the same thing. But conceptually, we understand it's different. Yes?
Pretty much.
And of course, we're trying to build our way up to multiplying fractions by fractions.
Yeah.
We have to do it step by step. The shit does this mean?
You're cutting down a whole into a fraction. And you have to like bring it down
So-
to the term.
Let's really think about what this means. 3 times 2, let me put it here. Okay, so 3 times 2 would be, what did I put, 3? Ah, screw it. Let me do this, okay. So 3 times 3 would be 3 plus 3 plus 3. 3, let's see, you could do it, Jeff. 2 times 3 would be 3 plus 3. Is that cool, everybody? Right? 1 times 3 would be 3. Ooh, okay. So every time I do this step, I'm losing like a 3. So 1/2 times 3. Okay. So here this is, I want 3 3s and I add them. I want 2 3s, then I add them. I want 1 3. And then I add them, there's only a 3 sitting there. So this one says I want half of a 3, right? So what you gotta think then is, what does it take 2 of to make 3?
Yeah.
So if I have 3, what does it take 2 steps of to make 3? Right, so we could even, so yeah, it's gotta be 3 halves, right, which we know is the answer, but that's why it becomes something you have to write as a fraction, because we are breaking it up into parts to get there. So this is what's really weird. 3 threes, 2 threes, 1 threes, half of 3s, right? Which is really the way to read this. It's half of 3. And this is really weird to me. As I've been teaching, I've noticed over the past 10, 15 years, people are coming out of high school not knowing what of means in math. It used to be automatic. If I said 3/4 of 80, 3/4 times 80. That's what of means in math, right? So like this would be, if I have 3 of these and they have 3 apples in each, then I have 9 apples. 3 of these crates with 3 apples, of means multiply, right? So if I have half of 3, that means multiply. Gotta lock it. Maybe. So what about 1/4 times 3? How could I do that? Visually. So I could start with, what's right in the middle?
What do you need for,
3 halves. So that would be the answer for 2 steps. And now I gotta think, what do I need? 1, 2, 3, 4 steps. So I just have to do this one more time, right? Yeah, so this will be something, this isn't the greatest thing in the world, but 3/4, 6/4, 9/4. So what is 1/4 of 3? Well, what does it take 4 steps of to get to 3? It takes 4 steps of 3/4. Which then, you know, you could talk about the fact that this is 1/4 of 3 means breaking 3 up into 4 parts, which is really what that fraction represents. Okay. So this isn't the horrible part yet. I mean, this is not that bad. You still kind of see this. Where does it become a little bit, I won't say horrible, but a little bit worse, is if both of the numbers I'm working with are fractions, right? Okay. The funny thing is it becomes easier to represent in terms of pictures. Another way to do, real quick, another way to do this is if I have 3 objects and I cut them into fourths. Let me see, how do I want to say this? So if I cut each one up into 1/4, right? So there's 1/4 of one, 1/4 of another one, 1/4 of another one, then what do I end up with? 3/4. Yeah. That's a little bit weird. So what about, how would I do something like, to make up another one, let's use that. Yeah. 1/4 times 3/5. How do I represent 3/5? How would I represent this visually? You guys know, how do I represent 3/5 visually? Right, it's one of the first questions 6-1 asks us. You can draw a circle, what's a little bit easier shape to work with? Just use a rectangle, is that cool?
Yeah.
But you can use whatever region model you want to, but let me, with my drawing ability, let me use a rectangle. Right? Trying to cut a circle into 5 equal parts, I don't know. So I want to cut this, of course, into how many parts? 5 of them. See, I did semi-good. Yeah, it's not too bad. Thank you. And of course, to finish it, that doesn't currently represent, that represents 0 at the moment. What do I do to represent 3/5? Shade in 3 of these. You can make sound effects if you want to while you do it.
It's a word.
Alright, now, 1/4 of this. So 3/5 was I had a block and I cut it into 5 parts and I took 3 of those parts, yes? So 1/4 of this means cut this picture into 4 parts and then take 1 of those parts. Well, how do I easily cut this picture into 4 parts? I'm going to draw lines the other way. So like I'm cutting, now I want brownies. Every time I do this, I want brownies. And I haven't had brownies yet, and damn it, I'm going to get a brownie today. Screw it. So let me cut this up. 1, 2, 3. So I got 4 parts now, right? I've equally divided that picture up into 4 parts. And I want to take 1 of them. Why are you looking like that? So what do I have? What is this? How many little pieces do I have total? 1, 2, 3, 4. 1, 2, 3, 4, 5. So how many pieces do I have total? 20. And out of those 20, if I'm taking, I really want you guys with me on this. We shaded 3 of the 5 because it said 3/5. So now 1/4. So I'm going to cut into 4. So I'm going to take 1 of those. So how many little shaded pieces do I have now out of 20?
3/20.
I have 3 that are shaded. And isn't that agree with what we know fractions, how they work, right? 1 times 3 is 3, 4 times 5 is 20. But the beautiful thing about this picture is now you see why these end up multiplying. Because of course we know if I cut a pizza in half, and then I cut those in half again, 2 times 2 is 4, that's why it's a quarter, yes? And if I cut each of those in half again, right? 2 times 4 is 8. There'll be 1/8. You guys semi with me? But that's why this picture where you actually cut, maybe you can bring brownies in. That would be a good day, right? Chop, 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 chop. There we go, kids. Now I'm going to eat all these myself. Let's keep going. No, that's probably bad. This is the way you could do any fraction. Now, obviously, we're not going to make you do like crazy big-ass numbers here. That would drive you a little insane. But the idea extends. Okay.
Who wants brownies? Next class.
Definitely want brownies.
I'll bring them.
They don't even have to be special.
They are not gonna be special.
Okay. Probably.
I've
Probably.
got enough to go around.
It's probably better. Okay, so what we've basically just shown evidence for, and I could have put any fractions here and they would have worked the same. The bottom is going to come from this times this, and you can see that. This is like the definition of multiplication, right? When you have certain, and then you cut it again, you're multiplying, it's got to be 4 times 5 to see how many brownies you got, right? So that makes sense. And then it's going to, now watch this. What if let's do this. What about if I had 3/4 times 3/5? Then it would have been, okay, 3/5, bam, 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 bam. Then I would have come in with cut it in 4ths. But now I would have taken 3 of them. So now I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 20. So every time I do this, I notice it's the same idea. The total number is going to be this times this. Of course it is, because that's the definition of multiplication. And the top number is going to be this times this. And again, that's also like a subset like this. This number would tell me how many this way, and this number would tell me how many this way. That's also the definition of multiplication. So that's why we multiply tops and bottoms of fractions. You can see a visualization of why that's true. Maybe. Okay, that is one little thing that people seem to still have some trouble with understanding why that works. Okay. So, how about, all right, here we go. Well, real quick, before I go too far away, can you guys do, can you do 7 over 11 times 5 over 9? Sure. What was that?
You want us to try?
Yeah, do. No, don't draw it. Sorry, don't draw it. Oh my God. Oh my God. What have we just figured out? If I have, sorry guys, oh my God. If I have A over B times C over D, what have we just figured out? The answer is going to be AC over BD. All right, so just make sure you guys got the idea. We're going to do several in a row. They're going to get worse and worse.
35 over 99.
Yeah, so this is obviously 35 over 99. I'm glad somebody said something. I would have been like, what are you guys doing? What's taking so long? What's wrong with this damn picture? All right. I understand. What about, yeah, let me go here next. What about 84 over 140 times 25 over 39? By hand. Does anyone have a suggestion on how to make this simpler?
You can, the 140 and the 25, can
Yes.
be both divided by 5?
Yes, right? Since I would do, now see, this is where I would end up, correct? I would do this. And I don't want to do that, right? Because I'm making you do this by hand. I don't want to do that shit by hand. Right? Okay. Since I would put them all together, then any factors of anything on the top will cancel with those same factors with anything on the bottom, because they're going to end up on top of each other anyway, right? So, you noticed both of these are divisible by 5, right? So 5 goes into 25 5 times. 5 goes into 140 28 times. Anything else?
Can you divide 84 and 39 by 3?
Yeah, 8 plus 4 is 12 is divisible by 3, and 3 and 9 are divisible by 3. So 3 goes into those. 3 it goes into 84. Interesting.
Whoa.
3 goes into 39. And of course, what happens now? Big time.
1 over 1.
Bam, bam. So then screw this shit. What's the answer? So there's a 1, 1, right? 5 over 13, yeah. Now, if you did 84 times 25, got a number, and you did 140 times 39, got a number, then you try to reduce, can you imagine how horrific that would be? So I'd rather reduce when everything's smaller, and then put things together, right? We're completely allowed to do that, because if it's on the top, and the same thing's on the bottom, they cancel. Why do they cancel? Why were we allowed to cancel a factor of 5 here?
Because they're multiples of each other.
Okay, there's multiplication. And what has to be present for something to cancel? I don't know how weird this question is from your perspective, but what has to be happening for something to cancel?
The like match.
The operations, there must be opposite operations, yes?
Oh, yeah.
So 2 plus 8,000 minus 8,000 is frickin' 2, because they just had opposite operations. They kill each other, right? So 5 times 5 and 5 times 28, the 5's cancel, because this is divided by and this is times. The top is times, the bottom is divided by. Opposite operations. Kick ass. So real quick, what about, just a really quick side note here. Can you reduce this?
Yeah? No.
Interesting. You've covered all your bases. I love it. So you say maybe on Tuesdays? I don't know. When I feel like it? No. So now I don't know if any are going to make this mistake, but the obvious mistake people would make is to cancel the 7s. From what I just said, what would you say to somebody who does that? How would you explain it doesn't work? What are the operations present? Addition and division. Are those opposites of each other?
No.
So how the shit would they cancel? They're not defined to do that, right? This was multiplication and division.
Yeah.
Kill, 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 kill. All right, that's fine. Maybe don't teach you a kid. Kill, kill. But my math is very violent. I'm sorry. But this, you can see why your brains, they just want to die, but they can't because the operations aren't opposite.
Can you break them apart though and do like 7 over 7
Yes.
plus 3 over 7?
So you could do it as long as you did 7 divided by 7 and 3 divided by 7. Because what does it say? What's being divided by 7? Both of them.
Yeah.
But the mistake is when people do this. 1 and they get 4. 1 plus 3 is 4, right? Well, how did 3 escape being divided by 7? That's not fair. Poor little 7 dude got cut down, and 3's like, not bad. All right, so this should be 1 and 3/7 or 10/7, right? Depending on whatever way you're supposed to be. Okay, I like it. So, I mean, that's remarkable to me. It's such a wide arching idea. If you think something's canceling, take a second and make sure the operations are opposite. That's the only way things can cancel. Yeah. Wait, okay, so what about this? Let's go, here's the next level. Oh shit. I think I'm on for you. You can make up a new problem, Jeff. Do you like this one? Sure. 3 and 1/5 times 4 and 3/7. Does anyone see a problem, or do you think this, can you just do this like straight through? No worries.
Wouldn't it be easier if you did like improper fractions?
Totally. Why? Why do you have to though? Why is the answer not 12 and 3/35? That is not the answer. If you think it's the answer, keep it to yourself. Because now you know you're wrong. But now you're like, what do you mean I'm wrong with this shit? So why, can anybody tell me why that is definitely not the right way to do this?
Too simple.
Some things are simple. You have to agree with me. Some things in math are simple, right? So that's not generally, you don't go, well, I must be wrong because I didn't, that took no time. What's between the 3 and the 1/5 understood to be there?
Plus.
A plus. Shit. So if you want to do this directly, when you guys have to FOIL, you see what I'm saying? Do you want to? So then we come back to your suggestion, right? This sucks because I have multiplication and addition. Do those play well together? No, not really. Not when you have multiple additions happening. Oh shit. So wouldn't you rather just go ahead and make this, change this all to be multiplication and division? Those play perfectly well together, right? So that means making them improper. So let's see. What does this become?
16/5.
31.
Is there anything you can cancel?
No.
Nope. You just multiply, right? Nothing cancels. It's almost nicer when nothing cancels because then you just blindly just multiply all the shit together. This is where people cross multiply for some crazy reason. It drives me a little crazy, but the top stay on the top, right? Because I really want you to understand this. What am I dividing 16 by? 5. What am I dividing 31 by?
7.
So overall, I should end up dividing by 35 because I'm divided by 5 and 7. Do you understand?
Yeah.
That's another way to look at why the bottoms multiply. Because I'm gathering how much shit I'm dividing by. And then I can gather together what it is I'm dividing into, right? So what is 16 times 31? 496.
496.
Sweet. Does that reduce?
Yeah, 14.
No. Now can you make a new X number? Does it reduce?
No.
How do you know it doesn't? Because it didn't here. Yeah? These numbers make these. So if these can't reduce, that can't either. Does that make sense?
Yeah.
So you could make it into a mixed number, but if you wanted to. Okay. You guys with me? Or if you had to. Blah, 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 blah. Oh, everybody's favorite part now. Let me kind of go through this a little bit quickly because we've already talked about these. Is fraction multiplication a closed operation? Is it closed? So when I say is it closed, if you operate with multiplication on two elements, two fractions, does the answer have to be a fraction?
No.
What kind of answer could you get that wouldn't be a fraction?
Whole number? Or
But aren't whole numbers fractions? Okay.
So yes.
Is there something else you can get? In fact, what's the definition of, what is this?
AC over BB.
Isn't that a fraction?
Yeah.
So that's closed. You can't get something that doesn't match what you started with. That's closure, right? If I can multiply two fractions and I get like a irrational number, like square root of something, that would mean it wasn't closed, but there ain't no damn way in hell you're gonna do that. Okay, I like it. Is that cool? So closure comes back. What about commutativity? Commutativity. Wait, what does commutativity mean?
They can move it.
I can feel some of you like shutting down right now, like, yeah, so you can move them, right? Isn't multiplication commutative? I don't care what the two things are. Okay, so commutative, it's commutative, associative, same way, right? Kind of inherits all these. What's the identity?
0?
No,
No.
that's for addition, because that keeps it the same. What do I multiply? Keep it the same, 1. Or you could say 1 over 1, if you want to make it a fraction, but we know it's still 1. You guys with me?
Yeah.
So all these properties basically come in, they're the same thing. What about multiplicative inverse? What would I multiply a fraction by to make it become the identity, to make it become 1? So the additive inverse of something is just the negative of that thing, for example. So what's the additive inverse of 7 is -7, because they kill each other. They become the identity, 0, right? So what do I multiply? So if I have a fraction like 3/4, what would I multiply that by to make it become the identity 1? You guys know.
4/3, you just.
Yeah, it's what? The
I forget.
inverse, I like it, or the
Reciprocal.
reciprocal. There it is. I like it. You can see why that happens. Couldn't I kill the 3s? Die! And couldn't I kill the 4s? Die! And then you get 1 over 1 over 1. Multiplying by the reciprocal. Does that phrase bring back any memories? Multiplying by the reciprocal. So for example, real quick, I know this is way in our future, but if I had 4/5 x equals 2/3. Oh boy! And of course, what's the whole point of solving equations? You're trying to get x by itself. So you're trying to make the coefficient of x 1, right? And then x will be by itself. So how do you make 4/5 become 1? What do you do to both sides? Multiply by 5/4. So if I multiply by 5/4, and I multiply by 5/4, doing it to both sides makes it legal. These cancel. And over here I get 5/6 because I can kill it too. Is that cool? All right, it's a little side note just to remind you guys where you might have heard the phrase multiply by the reciprocal. That's definitely one place. There's another place coming soon. Is that cool? Okay. All right, and of course, what about, oh boy, let me do this. All right, Jeff, get so much gooey from torturing people. Yes. Look at this beautiful thing. There. What property is this gonna use? What property could I use if I wanted to? Can I do distribution if I wanted to? Do I want to though? No, but I could. Right, so what would I do instead here?
You can multiply 1/4 by 2.
Yeah, top and bottom by 2, I'm with you. So that'd be 3/4 times 5/8 minus 2/8, so it should be 3/4 times 3/8. I'm doing this a little bit quickly. Now here's where I get interesting things happen. Somebody will cancel the 3's, for example. What's wrong with that?
They're on both on the top.
They're both on the top. Or somebody will make 4 and 8 become 1 and 2. They get a little bit reduced happy.
Yeah.
They start killing innocent people, right? These are innocent. They didn't do anything. Don't kill these guys. However you want to look at it. All right. Is that cool? Okay. and again, to me, the easiest way to tell a student that you see doing something like this is that these aren't opposite operations. They're both on the bottom, so they're both dividing. Why would they cancel if they're not opposite operations? So, no. Okay, let's see. Something. I have left a lot for today, so I'm sorry. Obviously, where are we gonna go now? We're gonna go a little insane, but what's the next operation that we haven't done yet? Division, I like it. So real quick, let's start off nice, right? Let's start off nice. If I have 8 divided by 4, I know you know what the answer is, but what's one way to interpret that? What's one way to interpret 8 divided by 4? What is it asking me?
Repetitive subtraction.
All right, repetitive subtraction. So another way to put that together is how many times would I have to subtract 4 to make it disappear, right? Twice. I love it. Is there another way to think of this? Sort of related to that, yes.
How many groups does it take for?
I know what you're saying.
Yeah. For
So let me help you out a little bit. How many 4s
Yeah.
would it take?
Would it take to make 8
Eight.
in each group?
To make 8.
Make 8.
How many 4s
Yeah.
would you add together to make 8? Which is basically the reverse of how many 4s would you subtract to make this disappear. Does that, you guys with me? We know division is repeated subtraction. But I like this. How many groups of 4 can you find in 8? 2, of course, right? So what would you put in front of a student, a younger student, for them to figure that out? How many groups of 4 are in 8? You sit in that table, what would you put in front of the student?
8 things.
8 things. And then what would you say?
Make groups of 4.
Make groups of 4. Yes, you're crazy. Holy shit. Okay. And then we saw basically almost exactly that before. Now, what about this then? What's one nice thing about this problem?
The same denominator.
You have the same denominator. Let me make it really clear, because I almost hate that I'm saying this right now, because when do you need like denominators? When do you need like terms? When you're adding, subtracting. You do not need them when you're multiplying and dividing. One way you can show somebody how division works is to get LCD. And let's see if you can see why this makes sense. 6 things divided by 2 things. Let me see if I can say this better. It's not 3 things. All right, you gotta be careful. If I have 6 things, Jeff. So one way to look at this is the same way we looked at this, is how many 2/7 fit in 6/7. So how many 2/7? There's 1. There's 2. You guys see that? You can, of course, you could do 8, 4, 1, 2 groups of 4, right? Same idea. So there's 3 groups. 3 groups of 2/7 fit in 6/7. So what's the answer? Say again, sorry. 3. I like it. How do you kind of check this? If that's true, how do you check it? Like if that's true, if 8 divided by 4 is 2, that means that 2 times 4 is 8. So if 6/7 divided by 2/7 is 3 is true, that means that 3 times 2/7 is 6. Yeah, it is, right? So you can always close that loop, show them how to check their work. Yeah.
I just have like a weird memory recall. Like I remember when we were dividing fractions, you switch like the sign and.
Oh, okay. Yeah. We're getting there. In this case, well, all right. This specific problem, because the bottoms were the same, I can look at it more directly. And we see why, and again, just to really make sure you understand, it's when I add things, they have to have the same denominator, right? So the fact that this had the same denominator meant that I could look at it like this. Add 2 7s, add 2 7s, add, holy shit, so 3 times I gotta do it. Now, we still have to prove, so tell me, how would you do this if I just gave this to you now and I said, you do it, just do it. You wouldn't do that. You wouldn't draw a number line. What would you do? 6 7s times 7 halves. And then look what happens. Right? 6 divided by 2 is?
3.
Yeah. So thankfully they match up. Does anyone know why you divide by, multiply by the reciprocal? So we're going to prove that in just a minute. Woohoo, yay, Jeff. Yeah.
Well, I don't know, because they're opposite operations, so you have to like switch. Like if you divide by 2, it's the same thing as multiplying by 1/2.
But why? They accomplish the same thing,
Yeah.
but you'd have to prove that for everything. So, all right, I'll show you in a minute. That's a little bit ahead. You brought that up, so I went there for a second. So, in general, if I have A over B divided by C over B, I don't have to do multiplication by the reciprocal. I really don't, since the bottoms are the same. Tell me, what would the answer be? 6 7s divided by 2 7s was 6 divided by 2, right? So what is AB's divided by CB's? AC, yeah, A divided by C. Okay, maybe. Okay. Oh, okay. Now watch this. All right. This is kind of weird. So what if I had A divided by B? Well, AB's divided by CD's. Could I make, or just go with me? We're going to eventually shed this need for an LCD. But could I make the bottoms the same? And don't overthink this. What is he missing that he's got? Missing, so let me see. So this would be A, I'm going to multiply him by D, multiply him by B. So I get AD over BD divided by CB over BD. And now I get the same denominator, right? Right? I made the denominator the same, didn't I? Right? We can always do that, yes. Then what's the answer? Using this thing we know. If the bottoms are the same, what's the answer? This top, right? This top.
AD
divided by
over CB.
this top. Let me write that as, isn't this the same thing? Yes? Let me just turn that around for a second. Yes? And isn't this A over B times D over C? Yes? And isn't D over C the reciprocal of C over D? Yes? So that's one kind of way to prove this. I don't like that way as much, to be honest. Okay. So the thing is, we don't want to have to find an LCD every time I have to do a division, because LCDs can get pretty damn gross. Do we all agree? Okay, we should. So let me show you sort of a proof. So we just showed that A over B divided by C over D equals A over B times D over C. So when you divide by a fraction, you multiply by the reciprocal. Let me show you another proof, and now I want to give you a physical interpretation. What? I have finally figured out within the last 5 years, I think, a physical interpretation of what this means, which I'm obviously excited about. We'll see what you guys think. Let me use concrete numbers for this, right? So let's do 3/4 divided by 2/7, right? By the way, this is a proof of a shortcut You are never going to do a problem like I am about to do. Does everyone hear me? You guys with me? I always have somebody go, what are you doing? Why are you doing that? Oh, shut up and watch it. So this is trying to explain to you why multiplying by the reciprocal works. How do I write something divided by something? Can't I put that thing over the other thing? Right? Isn't that basically how anything works? 7 divided by 3 is 7 over 3. Isn't that true?
Yeah.
All right. Well, you guys are excited, right? I can tell. So this would become 3/4 divided by 2/7. Do you like that? No. It's like fracception, right? It's my dumb joke for that, but oh well. I like it. I watched that movie again with a notebook. Anyway. Why does this really suck? Can anyone tell me why this really sucks? Why does this suck? You want to see a lot of these running around? This is what we call a complex fraction, because it's fractions inside of a fraction. So tell me exactly, why does this suck? Anybody? You go ahead.
You gotta do like the.
No, because of what you got to do. Why does it just suck on the face of it?
Denominators?
Oh, say again?
The denominators?
What
They're
about?
not the same.
Oh, they're not. Okay, but any number I give you that looks like this, would you want to see it like that? No, this is gross, right? So let me just come to the point. The bottom is really sucky because it's a fraction too, right? If the bottom wasn't a fraction, in fact, if the bottom was what? What's the best number ever to have on the bottom?
1.
1. Yes, does everybody agree?
Yeah.
1 on the bottom is so, it's like, oh, thank God. 7 over 1 is just 7, right? Even 4/5 over 1, that's just 4/5. Yes? Okay, stay with me. This is so cool. We just a minute ago came up with a way to take any fraction and make it into 1. Yes? What do I multiply this by to make it become 1?
7/2.
7 over 2. And if I do that to the bottom,
You have to do it to the top.
I better do it to the top. What's the bottom become now? Right? So it's 3/4 times 7/2 divided by 1, which doesn't do anything, right? I can just take the divided by 1 away. So what did we just show? 3/4 divided by 2/7 is 3/4 times 7/2. It's multiplied by the reciprocal, right? And the reason I like this proof better is because you can see the reciprocal actually happening. It doesn't just sort of like go, well, turn this on. No, you can actually see it happening. I don't know. So as long as you know to do that, but hopefully now, well, at least you've seen a couple ways as to why you do that. All right, now let me give you the physical interpretation. This is really exciting. If I have 4 full boxes of apples, yes? 4 full boxes of apples. And I see 6 apples in one of the boxes. How many apples are there? 24. There it is. I thought you were making like a dramatic pause. 24. Okay. Yeah, this is the basic definition of multiplication, right? And you're all like, what does this have to do with this shit, Jeff? I'm getting there. This is pretty simple, right? You know the boxes are full. You know there's 6 in one of them, so there's got to be 24 total.
Yeah.
Right? 6 apples fit in a box. Okay, I should have said equally distributed, but okay, that's part of the problem. So, what if there's 1 full box, and I see 2 apples in half of the box? Oh shit. Right? 2 apples in half of the box. Now, don't even think math. Don't even think math. You understand? Like there's somebody's put like a towel over half the box, so I can see 2 apples there, right? But I know it's a full box, right? Somebody told me it's a full box. You with me? And I'm scared of towels, so I'm not going to lift the towel. I'm like, oh, it's a towel. I don't know, right? Something happened to me in my childhood with towels, right? But I can see there's 2. I can see 2 of them in half the box. So can you just, without doing any math, how many total apples are in that damn box? So in half the box, there's 2, right? So here's the overhead view. Overhead view. Here's the towel. And I can see 2 apples in the box.
That's 4.
And I can't see half. So there's 4. Obviously there's 4, yes? Of course there's 4. So what this really is 2 are in half of the box. I don't know. I didn't really present that as well as I wanted to, I don't think, but that's the physical interpretation I can come up with. Right. I don't know, is that all right? No, you didn't like that? So if I see 2 apples in half the box, 2 are in 1/2, 2 divided by half a box, there's 4 in the total in the box. Okay.
I like apples.
I'll work on that a little bit. Apples are fine. Blah, 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 blah. Oh, no, I don't care about that. Yeah, I got that. Yeah, I got that. Oh, that's what I did. I'm with, okay. Oh, no, I'm remembering, I should have done this one different, but that's too bad for me. One last thing. Oh, this is really silly. I just said this basically, but the book makes a big deal out of this. A divided by B can be divided as A over B, can be written as A over B. That's remarkable. And they put it at the end of the section, and that seemed really funny to me. It seemed like an early thing to get over. There are a couple of, 6-3. It's like it's right at the end of the section. They're like, oh yeah, fractions mean division. Oh yeah, okay, don't worry. There is one little thing at the end of the section, and they talk about mental math coming back.
No.
So like, if I had to do 37 times 40 times 1/4, right? Would you do 37 times 40 first, or what would you do?
40 times 1/4.
Yeah! Do a little associativity. Because of course, what's that? 10, yeah. And another way to look at it, 40 times 1/4 is 40 divided by 4. Divide by the reciprocal. You can do it both ways. But yeah, you got 10. 37 times 10, 370. Easy. Okay. That's pretty good. That's a good place to stop right there. So next time, oh, there's more apples. That's funny. At the beginning of the next section, they have apples. We'll get into fraction, and right before you go, how do fractions, I'm sorry, did I just say fraction? Decimals. How do fractions relate to decimals? How do they relate?
We divide a fraction.
Okay, I'm with you. It kind of leads to,
Fractions become decimals.
yes. What is this? How can you read that? You can say 0.1, but how can you read that differently? 1/10. I really misunderstood. If something's gonna fit into our number system, doesn't it have to be based on 10 somehow, right? Why is this 4 allowed to be here? Because it represents 4 thousandths, yes? If I had 7 250s, would I have a 7 there? No, there's no 250s place. So decimals are just how fractions that have bottoms that are based on 10 look in our base 10 number system, right? So 2/10 would be 0.2 because this place, what place is this? Tens. Ones. Every time I take a step down, I'm dividing by 10, yes?
Yes.
So what's 1 divided by 10?
10.
Tenths. And then the next place would be hundredths. Thousandths. Got to get a little bit of a lift going when you're talking about the decimal. Right? I apologize if you have a lift. They named it the worst thing possible. All right, that's enough, guys. So I'll see you on Thursday. We'll talk about the next quiz Thursday.
Yeah, I'll bring brownies.
Oh, yeah.
No one's got allergies.